Thanks for tuning in to this episode of the In the House podcast. We have a great chat today. So we have Vish with Consulting Engineering Services out of San Antonio, Texas. And so what we're going to talk about today are, why mechanical, electrical, and plumbing designs are so critical, especially on, very high-end custom homes, but really any project can benefit from having an MEP design, from a remodel to a new build. We'll talk about the value of having a MEP design. And then we're also going to talk about, from a builder perspective or even a client perspective, what are some things that you need to know before pursuing MEP engineering? And then if we can, Vish, I'd like to talk a little bit about some of y'all's forensic services and some things that y'all find, maybe some common mistakes that you find during those forensic efforts. So
that'd be great.
Yeah, we're coming out of the weekend. It's a little chilly today. We're in a little bit different environment today, which I think is actually really good. It kind of makes it seem like we build stuff for a living. So, but before we get into all that, I think Michael, you have a builder shout out this month that we want to give some credit to, a local builder here in Austin who's been doing great work. So who do you got?
Yeah, builder shout out for this month is Lavaca Building Company.
Lavaca.
And what we find is that builders oftentimes want to go kind of bigger is better, right? They're trying to get bigger and bigger projects over the course of their company. And Lavaca Building Company has been around, I think they've been around about between 5 and 10 years, and they are strategically set to do small remodels, kitchen remodels, fireplaces, additions to houses, but they do it at a high quality level. And that's oftentimes a market that I always have people coming to me saying, hey, I don't have a big project, but I want it done well. And there's someone in that space who are doing high quality work at a small scale.
Those are the clients you want, really. I mean, no matter what scale, it's like, hey, I just want it done to the highest level of quality possible. Yeah. So that's good. Well, good for them. That's fantastic. So shout out to Lavaca Builders.
Shout out to Lavaca Builders.
And then you had some news for us. What's going on in the world today, Stolly?
I've got a 2-for-1 today.
Oh, 2-for-1.
The first one's pretty simple. It's as really most of the U.S. knows, we had this winter storm that just hit.
No kidding.
Yeah, I know. It's shocking,
winter
right?
Storm?
What?
Holy smokes!
Did you guys get hit very much?
Yeah,
I mean, there were some areas, parts of Tennessee, over through Mexico that got between 20 and 30 inches of snow, which is terrifying as a Texan to hear. I think we got here maybe 1/4 inch or something.
Hey, our street had at least 1 inch to 1.5 inches of ice on it.
Yeah.
So, I mean, you talk about shut everything down.
Yeah,
we get a little bit of ice.
That's shut down territory.
Yep, can't do anything. But the kids had a great time. So
I know, Vish, you used to live in Boston, so I'm sure you weren't scared by it. But
I was a little more scared about it over here because
everyone else like, oh crap!
Ice.
Yeah, we're not
don't know what to do.
Yeah, we're not equipped for it.
Yeah, that's true.
I remember 2021, I believe, when the Snowmageddon happened. I'd called our head office in Connecticut and said, hey, we can't go to work today because the state shut down. And they were like, what?
What are you talking about?
Snows in the Northeast, and it's fine. And they're like, then the news came out, and they're like, oh my God.
Yeah.
This is bigger than what we thought it's going to be.
That's true.
Yeah.
Oh, man.
Second piece of news I found this week, census came out that Texas has the largest population increase of any state for the 3rd year in a row.
3 years in a row. Wow.
3 years in a row. So a little, Texas flex here that had an increase of about 300,000 people.
Are they tracking, like, where are they migrating from? Is this from, other states they're coming to Texas, or?
No, this is simply just, basically census. So it's
okay.
So it's just numbers up and down.
So native Texans are growing in population.
Well, it could be people moving to the state.
Well, that's what I'm getting at.
But it could be both.
Well, hopefully, yeah, we're increasing in population, not going down. But
Interestingly, Hawaii was a decrease,
really,
and California, which is
That's
not very
not
surprising.
yeah, it seems like everybody you talk to nowadays, they're coming from California.
I
I
have,
got many clients that are from California.
yeah, a surprising number of people I've met from California recently.
A lot of businesses.
Welcome to Texas.
Yeah, buddy.
Eat some tacos.
We got the best. Awesome. Well, Vish, I really appreciate your time coming on today.
Thanks for having me.
Yeah, and so what I want to do, if you can quickly kind of give us your background and how you got into mechanical design.
So going way back, I mean, I grew up in India, did my undergraduate degree in engineering in India. But I remember when I was in high school, I wanted to be an architect. And my school advisors at the time said if I'd become an architect, I needed to do MEP design. And I was like, nah, I don't want to do that.
So that was a deterrent.
So I went to engineering because, my grandfather was a very famous engineer in India and inspired by him to do more things. And then I honestly thought I was going to get into designing aircrafts and such because when I finished my undergraduate degree, I took a master's in computational fluid dynamics at the University of Warwick, which is in the UK. And when I got out of college, I'm like, great, I can go work for BAE Systems. Guess what? I didn't have the security clearance at that point. So I said, okay, what else do I do then? So I ended up working in nightclubs and bars for a while.
Yeah, figuring it out.
And a couple of famous nightclubs in Leicester Square and such. And finally decided to go to a pub set of settings. And I was thinking of my career, should I continue with engineering or go into the service industry? Randomly, one person came into my bar saying he wanted to Friday drinks for his staff. And it was an engineering company. So I'm like, hey, so what kind of engineers are you? He's like, mechanical and structural. I'm like, well, I'm a mechanical engineer. The guy's like, you looking for a job? I'm like, yes. I'm like, you looking for a beer? He's like, yeah. So let's trade. So I poured him a beer. He interviewed me over the bar, and
That is awesome.
I got a job. I started with them on Monday.
That is
Hey.
so cool. That's
Love
such a cool
that.
story. Yeah. What are some wild stories about being a bouncer at a pub?
I was more running nightclubs, but I have been a bouncer too. It is just a different scene. I remember I was dating my wife now at the time, and I told her that I'm going to go to nightclubs the rest of my life, and I think that was the last time I went to a nightclub.
She was
Yeah,
like,
she wasn't down for that idea.
No.
yeah.
Yeah, good. Well, cool. Yeah, what a wild story. That's awesome. So okay, so you got into mechanical engineering, or you eventually landed back there. So how did you get at CES?
So when I was working in England, Brexit happened.
Okay.
And the economy was about to tank. And my wife, who's from here, she was like, let's move to the United States. So we moved to Denver originally because I was not going to move without a job.
Uh-huh.
So I got a job offer in Denver, got my papers situated,
Yeah.
worked over there for 11 months doing tenant improvement,
Uh-huh.
say 40 projects a week.
Wow.
Small tenant improvement, moving
Yeah.
a toilet, adding a vent to an office and such.
Yeah.
Did not like that. Did not like the cookie cutter world it was in. I liked
Right.
because my history in England was doing a lot of custom projects and high value projects for high net worth individuals as well as companies.
Right.
And I want to get back into that side of things. So CES randomly was one of the LinkedIn messages like, hey, do you want to, somebody's looking for, CES trying to hire you for this job. Would you like to talk to them?
Yeah.
So sure, we'll talk to them. And turns out they did custom homes, they did schools and police stations and good projects that I want to be part of.
Yeah.
They flew me out to Boston, interviewed me, and then I joined them a month later.
Yeah.
Wow.
And since then, I spent about 2 years, I want to say, in Boston when the opportunity for Texas arose. So we had a former colleague of ours was wanting to retire down here, and he came down in 2017, 2018 time to start the office. So I came right behind him and helped with the business development side of things, and obviously the engineering too.
Yeah.
Cool.
And since he is retired now, it's 2026. We are about 8 to 9 people, so to speak, in the office.
Yeah.
And I've done a bunch of good projects around the state.
That's great. Yeah. So how has it been? You've gotten experience developing mechanical systems in a variety of different places. I mean, from cold climates, but even to warm climates. But even just the climate and community of Denver, very different than England, very different than Northeast, very different than Texas.
Yep.
What has it been like all right, kind of what have you learned kind of moving in between these different places?
That's good.
You have to learn. You have to be open to learning new things, because building codes, for example, is very different from region to region within the United States, and obviously country to country too.
Yeah.
And then obviously the units too, right? Because we were metric in England. I came to the US, had to learn imperial systems, and then going to Boston, Massachusetts having its own building code, to Texas with 360 counties, with every county having its own version of a building code.
Yeah.
So you have to just be ready to roll when you start a project and do the research.
Yeah.
Right. Get in, go to the county website, go to the city's website, figure out what codes there, and figure out all the amendments, because some of the amendments are just buried into those websites.
Yeah.
Wow.
And then obviously advising the architect and the builder and the client on what building codes we're going to use, and discuss that and move forward with it.
Yeah, that's great.
Yeah. So kind of, I want to get into that same vein of, if you're a builder or you're a client and you maybe, you haven't done a project yet that utilizes mechanical engineering, what should a builder or a client expect? What things do they need to know, before diving in and reaching out to an engineer?
So number one thing is to look at the credentials as well as the portfolio of the engineer they're hiring, right?
Right.
Because a lot of folks who are in the MEP side of things are in the commercial side, right? So there's not that many opportunities to move into the residential side of things unless you have a good history of doing residential work like CES does. And obviously, I'm standing on the shoulder of giants. The folks who founded the company and have run the company for the last 30 years have really helped us build our reputation. Right. And I'm literally piggybacking off that with the portfolio that they have built.
Sure.
The other things to understand is the engineer going to listen to what you want to do, right? Because there is a reason that it is a custom home. This is not a production built home where you have hired an architect for their certain style of construction, traditional versus modernist or whatever it needs to be.
Yeah.
And the MEP engineer is supposed to complement that design, right? Even though I nerd out about all the fan coil units and condensers and things that we install on places, I don't want anybody to see it. I don't want to see it in my own house.
Right.
I want to make sure that my vents and things are in line with the ceiling pattern they have.
Yeah.
Things to consider is also, hey, what kind of artwork do you have? What kind of flooring material? How do you live in your house, right? Because my job is to design a system. Or when I say my job, residential MEP engineers, our job is to design a system that is custom to how you're going to live in that house, right?
Okay.
And the homeowner is the one who's going to tell me how they want to live there. How do you like to entertain? How long do you take showers? Do you want to, any kind of special items in your house, like a 4 kW coffee maker and steam showers and underflow heating, right? So it's very important to ask those questions. So we specialize in asking and listening to the client on how they want to utilize their home.
You get any wild requests?
Yes, plenty. I've been asked to AC porches, to front driveways, and
AC and exterior porch.
Yes,
That's awesome.
It's more us than people think about. But obviously, at that point, I tell everybody that the company's name is Consulting Engineering Services. Consulting is the first part of the name. Yeah. Where my job or our company's job is to advise the client on how and what is correct, what is the right way to do things, as well as what is going to work and not work. Right. We are not the kind of folks who will just do something just because somebody asked us to do it. But at the same time, we're not going to say no to somebody till we explain it to them on the pros and cons of everything. And then engineer the product.
Yeah, 100%.
That makes sense. Yeah, we're very much the same way. It's like, it's not a no, but let's at least weigh the pros and cons before we make a decision here. So yeah, totally. Well, that's great. What percent of residential work versus commercial work do you do?
So in Texas, my team does 50% residential and 50% commercial.
Oh, wow. Okay.
And on the commercial side as well, we're looking at historic renovations and high-end restaurants and hotels. And obviously we do the offices and coffee shops and things like that too. But it's more driven because of the client that we are working with. So if a good client of ours, let's say it's like Douglas, comes to us and says, can you do a coffee shop? We will do it. Right? Because it is the value that we add to the client that is more important than the project type in general for us.
Yeah. No, totally.
That's well said. It focuses on partnership and not product.
I want to be your go-to guys for anything that you need.
Yeah. And obviously, from a builder's perspective, I'm sure it's much easier on you guys the earlier you're involved with the project versus later. right? I mean, that way you're working hand in hand with the architect and the client, and you're getting their expectations and setting your design parameters. And then you're also working with the architect as far as, hey, where are we going to put all this equipment? What is where are we venting? Where are the returns and supplies and all that? So
Earlier is obviously better. I mean, it's like, we can also get involved later on in the project, but it's, now we have to ask the client and the architect to drop ceilings and things like that, which is not going to happen.
Yeah.
Disappointments on all fronts with the client too, when they think they're going to get something and we come in and change everything, right?
Right.
So every time I start a project and somebody calls me and says, we are going into design development, contract documents, and then we're going to call you, my answer is always pump the brakes, call me now, just send me what you have,
Yeah.
so I can at least give you advice on what's going to work for me or not.
Yeah.
Because end of the day, if, we are all in the same boat, right? Contractors, engineers, architects. And we don't want to give our industry a bad name by saying to the client later on during construction, saying you have to change all these things in the
Right.
closet that you really wanted. Now I have to put my mechanical equipment in.
Yeah.
I'd rather have that conversations up front before it's too late. At least that way the client can calibrate their expectations as well.
100%.
And design changes can be made on the architectural side to be able to accommodate my systems.
Yeah.
And vice versa, right? The architect says that, hey, this is not the right spot for your for this MEP systems. We can obviously talk about other options, and we have more flexibility with the day one.
Yeah, that's well said.
That's very true. Yeah, you have more flexibility the earlier on in the project.
What are some call them pet peeves that you have with dealing with a team early on? You have builder, client, architect, they come to you. What are some ways that teams come in that you often feel like you're banging your head against the wall?
Pre-formulated opinions, generally.
Ah.
Folks who've been building homes for 50 years, and like, I've been doing this way for 50 years. Why are you changing it?
Yeah.
Right? And if that person's open to listening, we are happy to explain. But if they are not, and they're very opinionated on how they want to do things, we are probably not the right fit, right? Because we expect that on the other side of things, where we are designing something, and say an HVAC contractor or somebody is installing my design, I want to make sure that we listen to them and they listen to us as well, right? It's a collaborative process, right? One person doesn't take precedence over the other, and as long as we can, have that collaborative work environment, it's going to be smooth sailing.
Yeah.
But then the other side also is when people kind of come in fighting, for lack of better words, of why a MEP engineer was hired, and that they could have done it simpler and cheaper the way they wanted to. Yes, that can be done. However, are you designing a system for the client's expectation, or are you designing a system just for cost, right? There's two different ways, right? The clients we work with, the high net worth individuals, especially in the custom home side, people who can afford to hire good contractors such as yourself and the architects that we work with, they want certain things, and we have to kind of at least entertain that idea versus giving them a system that we think is right, and which might not work for the house they want to have.
Right.
Yeah.
Yeah. No, that's very well said. I mean, that kind of goes along. I was going to ask you, what value does an MEP design bring? But I think you really hit it on the head right there. It's like you're designing and tailoring a system specific for the client's needs, and you're not just throwing darts at a dartboard and hoping you get it right. I mean, there's many times where you go into a project, and you could probably talk about this, and even some of your, like, the forensic stuff that you do, where the system just isn't performing to the client's expectations. They turn down the thermostat, and they're trying to get it to be 68 or 70 degrees, and it hits 72, and it just won't get there. And it's like, well, why doesn't it work? Well, obviously the system wasn't designed to get to 68 degrees, right? So there's some problems there, and so I don't know. Can you go into that a little bit about, what are some problems? What are some common mistakes that you find, whenever you're doing peer reviews or, these forensic type investigations on existing projects?
So we don't really do forensic type investigations. We generally do peer reviews on a case by case basis with clients that we have good relationships with. Because we're in the design business, we're not in the review business generally. Things that I see, is either obviously the system calculation, that the system is designed without talking to the clients on how they want the house to perform, which is obviously the biggest key. And every time we start a project or a peer review, We always ask the same questions that we do for a project that we are designing ourselves. The second one is like million feet of flex ductwork, right? We see that quite a lot on things.
It's easy.
Run the flex.
Balancing the system, having a good test and balance, and a report sent to us. That generally gives us a lot of information on how the system is performing built versus how it was designed, right? The engineer who designed it or the contractor designed it could have had the best intentions behind it and asked the right questions, but was the install done correctly? I'll give you an example. We were at a job site where it was a powder room originally. We had about 50 CFM of exhaust. Then apparently during construction, it became a full bathroom, and the client was complaining about how the moisture was leaving the space. And somebody decided to put a 400 CFM fan instead of a 50 CFM fan. Now we went in there, the fan wasn't working. We looked at, put a hand towards the cover plate of the fan and things. So we went into the mechanical room, opened up the fan was blowing, we could feel the air, but no exhaust, right? So what's going on? Obviously, as engineers, we're thinking about the fan curves and all those things. I'm like, wait a second, there's got to be something much simpler than that.
Right.
So he spoke to the HVAC contractor and said, well, can you run a camera through the ductwork to see if any duct has been dislodged? Turns out it was. So some of the solutions could be as simple as that, right? Just pay attention to the work that you're doing and don't disrupt anybody else's work.
Yeah, totally.
Yeah.
Well, so you made this comment about flex duct, and I'm interested to hear your thoughts. Like, you mentioned that as a negative, right? But you see flex duct used. I mean, it's very common to use flex duct, for AC systems. But what are some issues with it?
So it's good for certain things and not good for certain things, right? Example, in my house, I'm in a production built home that I live in. I have all my attic is flex ductwork.
Yeah, mine too.
Yeah, but my HVAC unit is about an inch and a half of static. So it can help push through the air. I'm also not sleeping at 65, 68 degrees in the summertime. My house is maintained at 75. So it works for me, right?
Okay.
Could it be better? Yes, because I do hear noises through that. My fan performs a little harder sometimes, a really hot day or a really cold day. But the modern systems that we are using, most of the homes that we work in, we zone the house into different areas and such. That means we have more systems. Now, what happens? We have more systems in closets, in just above, say, master closet or primary closet. There could be noise transfer, right? The flex is good with some noise mitigation. However, when the unit is sitting right there, we have to have a much quieter unit, which have less static pressure. And when we try to push all that air through that system, it just creates more resistance on the fan, which can now create more noise issues from the unit itself.
Okay, gotcha. So it's kind of just the flex duct is causing more internal resistance, basically, and the fan's having to work harder.
Yeah.
So more wear and tear on the unit and more noise.
Yeah. The other one we also see is that when there's a lot of flex duct work, especially in the tight ceilings that we work in, they can get pinched.
Yeah.
Right.
I see that a lot.
By the time you put the spray foam insulation, you have all the conduits and things. With the rigid duct like a sheet metal ductwork, you can modify them to have the size that you want between trusses. It's much more durable. It can take a little bit of beating compared to a flex ductwork.
Yeah, exactly.
Yeah.
Love it. Well, so what I kind of want to get into a little bit, and we talked about it earlier, was AI and the introduction of AI in the MEP world and really just design and construction and architecture in general. And I'd like to get some of your thoughts, if you can, on how, if you're implementing AI, and like is it a useful tool, and how y'all go about doing that.
I mean, at the moment, the AI tools that we're using are to write, say, design narratives, some marketing, some analytics, tools with Revit. It's not replacing engineers or the design we do. We're also looking at AI-based controls, like Josh AI. Mitsubishi, I believe, has come out with some kind of AI thermostat.
Yeah.
So we're looking at those things. But design-wise, we are still having engineers design it.
Yeah.
Partly also because the homes that we're designing are custom. We're not designing huge warehouses and data centers where we can copy and paste, in lack of better words, with an AI-based tool.
Yeah.
Right. These are we're talking to clients, we're talking to the architects and the builders and everybody about every inch of this house. And that requires a human to be able to understand and appreciate what is being done in those areas.
Yeah. So you can't just type in a bunch of information and then the computer will spit out a MEP design for you. It's just not that simple.
That actually scares me more than it. I'm looking forward to it.
That causes more problems than it solves.
Yeah.
I'm sure we'll be there one day, but it's not there today.
Yeah, is that possible? Yes. Is that the best solution? No.
Right.
Is how I would word that.
I mean, I've even seen videos, people do that with architecture, right?
Yeah.
They say, oh, generate a floor plan or something.
Yeah.
And, at first glance, it's like, wow, that's pretty good. And then you start really analyzing it and you're like, they have, doors that go to nowhere or they have like, windows and interior spaces and just things just don't really make sense. And it's like, it's a long ways away. I don't think we're quite there yet. I mean, and especially, you're talking about earlier with code, like code is very regional and it changes. So it's not like you can just use an AI model to pump something out, because it's probably going to be totally off, with the code requirements. So yeah, I wanted to get your thoughts on that, but I don't know if we're quite there yet.
No, that would be an area where maybe if especially with you guys being a larger company, multiple offices, dealing with the complexity of the code, I do wonder if there's a way for you guys to use, AI to help sift through that data. I'm sure there's so much time digging through, these terrible city, websites, finding
city
things, and maybe that's an area that could be helpful optimization for AI.
So I believe ChatGPT and Upcodes have made some kind of a platform where you can kind of research some codes over there. But
Upcodes is cool.
But most of the PDFs we use generally to look at the codes or the book, at least on the PDF side of things, it's all searchable. Right. So we know what we're looking for and read through it, including and creating a large model language with all the codes out there. I feel should be something the ICC should be doing and provide that tool than individual companies. Right. Because it's a resource hog. Right. And if ICC wants more people to be code compliant, it's something that I'm sure they will be looking into. That is the future. I'm sure there's some talks about it.
Yeah, probably.
Do you think energy code is like too restrictive in some ways?
Some ways, but it also benefits for the time we are in, right? The world has changed very dramatically in the last 30 years.
Right.
If you think about it, right? We changed freons multiple times and things. So the energy code is just trying to be reactive based on what is available in the market today. Right. There are some pros and cons. There's certain things that folks don't agree with in the energy code, but the code exists to safeguard people from themselves. Right. The analogy I make, and I think Lonnie, I heard you say this on a previous podcast about car analogies. It's easier to explain that way.
Oh, hey, that makes sense.
Right. If
that was Michael. That was a good analogy.
If I have a speed limit on a car for 80 miles an hour, the speed limit exists for most of the people, right? Say Michael Schumacher might be like, listen, I can drive this thing to 400 miles an hour. Right? Yes, for one person. But if we give that opportunity to everybody, it is going to be the Wild West.
Yeah.
Okay. Yeah, that makes some sense. And I like how you said that. It's code is there to like save you from yourself. Why do you say that? Do you think because people would just go ape shit and go crazy and just design a bunch of stuff that doesn't work and just because they can?
Or over design it, under design it, the system doesn't perform the way it needs to. Like example I would give is that outdoor AC that people asked me for. That's energy code violation. That's a case in point exactly why we should be using the energy code.
Well, that's true freedom though when you think about it, right? I mean, that's why I say it's like it feels like kind of restricting. Like if I have the money and I want to put AC outside, then why the hell not, right?
We have a lot of clients in ranches and rural parts of the country where we get told a lot that there's no building codes here.
Right.
Last time I checked, we all live in the United States. All these projects are here, and there's building codes in every jurisdiction you go to.
That's good.
Right.
And the other items also, yes, in your homestead, you can do whatever you want. But if you've hired a professional service such as ours or an architect and folks like that, we have to abide by the building code.
It becomes a liability to you guys.
Exactly.
Yeah. That makes sense.
One thing that we were just talking on a recent episode was about lighting design, and something that's changing over the time is the desire for clients to have something that's not a static system, that changes to the needs of the client. I think, from my experience, we're seeing that similarly on the mechanical and HVAC side as well. I'd be curious to hear your opinions on that, about how are you guys addressing and thinking about systems that, it's not, hey, the ask isn't now, hey, just can keep it, this one temperature throughout the year. The ask is, hey, there's a range of temperature, and certain times of the year we want it this, and certain times of the year we want it that. And I don't know, how are you guys addressing problems like that?
So we ask our clients what temperature they want to sleep in and live in, and things in the summertime and the wintertime. Like fireplaces, do you want to run the fireplace in the summertime, kitchen hoods, and all those things. It is not as dynamic as lighting controls would be. I think I heard that episode. But we have a certain dead band that we need to be in, right? So say a client says, I want to sleep at 68 degrees. Okay, we can do that. And they come back and say, well, it's not getting to 64, right? Or 62. Sorry, the system is not sized for that, right? Because we are just constrained by the restrictions of the unit performance by itself.
Right.
If you think about it, AC was invented in 1902 by a Carrier. It's been almost 125 years, and it hasn't evolved quite a lot.
Right.
Maybe in the last 20 years. But it's still the same parts and pieces with certain tweaks to it.
Right.
Yeah.
I guess there's a lot of updates as far as like the controls, maybe like the computer systems and everything that they've added over the years. But I mean, I guess as far as how the system actually cools the air is remained unchanged. Did you? I don't know. Since we're talking about past episodes, did you listen to the episode, or are you aware of the one with Erica? We did about 1,000-year home.
Yes.
So one of the things that we didn't really touch on, because we're not mechanical experts, was how to design a mechanical system that's going to, that's really designed for longevity, right? And so it was kind of a thought experiment that we did, where how can we make something last for 1,000 years? So I don't know if you can weigh in on that a little bit as a kind of a follow up to that episode. Like, what's the perfect environment? How can we set up a system to be like max longevity?
Wow, a longevity, HVAC system.
Yeah,
that's a tough one.
That's really interesting.
So ASHRAE, which is lack of better words, kind of a governing body for MEP engineers, or these mechanical engineers on a professional organization or society, so to call it.
Yeah,
they publish data where they tell you on average an air handler should be within 10, 15 years, a rooftop 15 to 20 years, or whatever the numbers are. There's a whole piece of paper with it. We try to stick to that. Because manufacturers warranty a product for 10 years, right? We can't promise something longer than that, because at the end of the day, they're moving parts inside it, right? You have a fan.
It's a machine.
It's a machine. Refrigerant coils. It's like a car. It's like saying that, hey, how can I make my car run for 1,000 years, right? With good maintenance, really, right? Number one.
Yeah.
We all seen those TV ads of certain companies are like, hey, I had my AC in high school. I made it work for 30 years, right? It all depends again on the maintenance contract side of things.
Yeah. Right.
Change your filters on time. Keep an eye on your product. Make sure the refrigerant's charged correctly. Your ducts are cleaned. All those simple things will just keep things moving better.
Are there any like commercial type units that are really designed to last more than 10 years? I mean, 10 years seems kind of short, in my opinion, for a...
It depends on the product. So I think rooftops, I want to say, is 15 years. Chillers, maybe 15 to 20 years or so. So there's different data based on different things. But when was the last time any of us put a rooftop on a house?
Yeah, exactly. Yeah.
So, and that's something we did touch on in that episode was, these moving parts and pieces are going to require more maintenance, and they're going to be replaced more often. So to design the system in a way where everything's easily accessible and you can swap out parts and pieces, and that's really how you're going to improve the longevity.
It's crazy to think of. You have a house, like if you're building 1,000-year structure, wow, you would need somewhere between theoretically 75 and 100 units. That is crazy to think about.
Yeah, that's true.
That's a lot. That's a lot of HVAC.
That's a
units.
lot.
I mean, you can probably stretch them out. I mean, manufacturers notoriously are going to err on the side of caution, right? When they're
That's true.
when they're warranting a product. So, I mean, I think the HVAC unit at my place is I think it's a 20. It's on its
Yeah, I mean,
somewhere
like
in
you
the
said,
20th
I think
year.
if it's installed in an ideal environment and it's properly maintained, I mean, who's to say you can't get 50 years out of it?
Yeah, you probably could stretch
Right?
it some.
I mean,
but
Maybe that's pushing it, but obviously you're getting way more than 10
no,
years.
but you're probably able to stretch that. But still, it's interesting. It becomes much more of a cycle of both maintenance and replacing and designing the system for that. And
Yeah.
It's really interesting.
Well, if they stop changing the refrigerant every 20 years or so,
Yeah,
I'm sure
that would
you
also
can
make a
find
big
some
deal,
more
yeah.
What's up with
longevity
that?
out of
Why,
that.
why are they
Yeah.
changing the refrigerant?
Global warming potential.
Oh, good Lord.
Yeah, it's
Global
pretty
warming
crazy.
Potential.
Well, and the interesting thing is it's still Freon.
Okay.
Going back to your point about the system, back from when HVAC is committed, it hasn't changed a whole lot. I mean, I think this newest one, was it 2025 that they changed the Freon?
Yes,
Or
2024,
2024, 25. That, but and correct me if I'm wrong on this, but I think the change in Freon, I mean, overall, it's still Freon. It's still a pretty similar.
Yeah.
Um,
Well, what are they changing with it exactly? I'm kind of naive to this a little bit, so I don't
believe
know.
it's the chemical composition of it
Okay.
on how it conveys the heat and cold through the space through the system itself. There have been conversations, and I believe there are products out there which use nitrogen, I think, and propane. I want to say as a so-called refrigerant for things. I haven't used one myself. I'm definitely not putting one in the house.
Yeah,
that sounds.
it's a bomb waiting to go off.
Yeah.
But
The insurance on that place would be insane.
Right?
the research is being done on a day-to-day basis. We have to have a more efficient Freon and an efficient system, because the industry is recognizing the amount of waste that is with changing these units out every so often and change the refrigerant, creating just a bottleneck with clients too, right? So when the refrigerant change was happening last year, and we had so many conversations with clients where they were like, can we get the new units? Manufacturers saying they didn't have it, or they didn't have the information on it. So there was a whole black hole for a minute
Yeah.
where we were trying to figure out how to get through this.
It's so challenging.
So they're changing the chemical composition of it. Is it improving the refrigerant? Like, is it actually is it able to cool better? I mean, what are they actually doing with the refrigerant that's supposedly making it better?
I'm not the expert at it.
Yeah,
that's
that's
a conversation
good
to have
question.
with the
It's so odd,
manufacturers.
like they
Yeah.
change it, but it's like what improvement has actually been made?
Yeah.
Like you said, this global warming,
Yeah.
potential. Like,
Right.
What the hell does that
They
mean?
haven't given us the chemical composition of these
Yeah,
refrigerants, so
that's,
I do not know the answer
well,
to that.
It's a little bit of cat and mouse too, because I mean, obviously these are companies and in industry, so there's some industry, trade knowledge where people obviously don't want their stuff replicated. So it's a little bit of a dance of
What it
the
feels like to
information.
me is when like a drug company changes the chemical
This is
composition
similar.
of a certain medication,
Yeah.
and I guess that they can patent that or whatever. It just feels like it's a money grab. But that's just my opinion, but
it could be.
If
It could be.
they change the refrigerant, it's like, oh well, now you gotta get a new unit or
Yeah.
whatever. I don't know, but
Yeah, it's tricky.
it is tricky. But Vish, hey, I appreciate your expertise, and I appreciate you coming on and talking to us about everything that you do and the value that you bring to construction projects. So again, thank you for your time, and thanks for coming on and talking with us.
Yeah, happy to do
Yeah.
it. Thank you so much for having me.
Awesome.
Thanks.